Azure Container Apps is kind of new as of, a couple of years. And it's out there. It's a part of Azure, and people are using it. And a new big revision just was released with Azure Container Apps to kind of change some things. So if you looked at Azure Container Apps when it first came out, but haven't done it since, then there's another big revision. But I also want to do it in the context of .NET 8 and Kubernetes and containers just in general. But overall, the promise of it is to lower production costs while increasing deployment and operations flexibility. And and it can run basically anything, but you put it together with .NET 8, and it's a really powerful combination for custom applications. And you can drive down the cloud costs. So we're going to see how these fit together, and we'll talk about which parts fall nicely into place together, and maybe where the rough edges are. And my hope is that you'll come away knowing what architectural choices to make for your next Azure and .NET project. So just a quick overview of where I'm coming from. At Clear Measure, we're a full service software architecture and engineering firm that serves companies that are building business critical software projects using Microsoft technologies. And you see a cluster of technologies on the left, and a heavy focus on doing a great job at software is Agile, is DevOps, is software engineering practices, is design patterns. And so that's where I'm coming from. I've been programming since 1997, and largely the Microsoft platform the entire time. Before I kind of get into the topic, I have my latest book, .NET DevOps for Azure. I have an agreement with the publisher. If anyone would like a full electronic copy of the book and you don't have it, just send me an email. It's on the screen, and I'd be happy to send you a copy. And hopefully within about another month to a month and a half, my 5th book will be published. And I don't have a picture of it because it's not quite ready. But if you're interested, if you lead software teams, it's called The 5 Pillars Software Leadership for Effective Custom Software. And so that one's coming out, and it's aimed at people who are leading software engineering teams, as opposed to a particular technology, or whether .NET 7, 8, ASP.NET MVC, or DevOps. So that's where I'm coming from, and my belief for everybody, and we do it at work too, a Clear Measure, but my belief for every programmer is, and every programming team, when equipped and trained properly, every team can be successful. Every team can deliver world-class custom software. And that's what I'm motivated for. I also, besides user group talks, I love to facilitate various forums, and we have one called the Software Architect Forum, and we also have another one called the Software Leadership Forum. But either way, if you manage a software team, or if you are kind of a lead engineer or architect of a software team, I facilitate some meetings that you may be interested in. All right, let's dive in Azure Container Apps, and let's just talk about the themes of this latest wave of .NET 8 and how it interacts with Azure. So a big theme of .NET 8 is to make all of .NET applications cloud native. And there's some themes that go within there: observability, resiliency, scalability, manageability. But the big one in this theme that's being pushed out from the .NET side is observability. And there are some extra libraries that have come into play that, yes, you can use them on any .NET application, but they really fit well like a glove when you're deploying to Azure Container Apps. So there's some libraries in NuGet. If you've never heard of them, If you've never looked them up, I'll just highlight, for example, extensions.diagnostics.healthchecks.common. It's on the left side, and that adds the ability to have an abstraction for various health checks. And it adds an interface to your services collection, to the built-in IOC container. And then you can have any class that implements the interface, the iHealth check essentially, and you can run a few lines of code that check on something. And then you have this API, this URL, call it whatever you want. I'll show you a little bit later. And effectively, when you call that endpoint, or you have a monitoring tool, call that endpoint, every minute or so, it goes and finds every class that implements the iHealth check interface, and you're running all those little tiny bits of lines of code, checking various things to make sure that every part of your application is online, is working. Because, for example, if there's a hiccup with the network between the application and the database, or a queue, or your connection out to a payment processor, or a connection with Azure files, or just any integration point, then some function of your application is going to have a hiccup, and you don't want to wait until your users complain about it. You want to know right away. So at the minimum, you want to implement a health check for absolutely every integration between your application and something outside of the process that your application is running in. So that's a no-brainer. And there's a lot of other libraries, but they're under these themes. Okay. And we're going to go deep into everything, because there's all kinds of content from Microsoft that covers every single one of these. Along with being cloud native, there has been a big push over the last year, specifically for containers, and inherently the containers are running on Linux images. So with .NET Core breaking away from .NET Framework 4.8, and that dependency on Windows has been broken, where now .NET 8 can run pretty much anywhere. Now, the big place you want to run it is on Linux, but not just running on Linux, running it inside a container in Linux, or for testing purposes, running it inside Windows subsystem for Linux using Docker Desktop on Windows. And so there's been a lot of work to make the container story for .NET easier, smaller images, more compact, having non-root base images, a non-port 80 default port, just for a little bit extra security layer. So there's been a lot of work put into that. So in the theme of containers, there is container size improvements, and that has been phenomenal. You can just look at the graph and see, how much smaller each of the container images are. All right. Just know, and they keep on working on that. If you didn't look at the content coming out from .NET Conf last November, or some of the more recent announcements, you definitely want to look at .NET Aspire. It came out it came out really just at the past build conference, but it was announced at the .NET Conf when .NET 8 came out, and there's going to be quite a bit of improvements with the .NET 9 wave, but .NET Aspire is going to really streamline your applications and make it even more simple to be Azure cloud native. And I'll touch on this. It's not a deep dive into Aspire, but just touching on what it provides. And the most exciting thing that it provides for me is dependency. Yes, metrics, distributed traces, and structured logs, it makes those more streamlined. But there's been solutions for that for a while. It just kind of makes it more automatic for .NET developers, so you don't have to think about it. But managing the dependencies is huge. And I'll kind of show you what that looks like. I'm just going to fast forward here. We've never had this, by the way, is the new project type called the .NET Aspire App Host. We've never had before inside the structure of a Visual Studio solution any type of code that actually described the structure of the Visual Studio solution and the dependencies of the runtime dependencies of each of the projects in that Visual Studio solution. There's been project references, which are build time dependencies, but not the runtime dependencies. And so with .NET Aspire, the promise of it is if we describe the runtime structure of the application, which, by the way, an application can have multiple different processes. You could have a web application, you could have a web service project that's deployed, somewhere else. You could have a web job. You could have a SQL Server database. You could have a Redis cache or anything else. And so you have multiple deployable processes that live in the same Visual Studio solution. And that's actually normal. And that tends to be the way it is all the time. And even if you've pushed on the microservices pattern a little bit and decomposed a lot of things, you end up with Visual Studio solutions that still have more than a single process to deploy. Logical independent services can still have, and very often do have, multiple processes to deploy, even though from an architectural perspective, they are a single logical service. So what .NET Aspire does is provide this code right here to allow you to describe it. And then there's tooling like the Azure Developer Console to allow you not to have to create your own ARM templates, Terraform templates, Bicep templates. It basically uses this code to generate on the fly the Azure resources in your DevOps pipeline and effectively give you an infrastructure as code capability in a more streamlined way. Now, I will say we're on version 1 of .NET Aspire, and the command line story for complete DevOps automation is not there yet. And so if you kind of jumping straight in, just be aware, version 1 was released, and the totally unattended command line story is not yet there. Right now, running the command lines with the authentication and service keys and whatnot, it does require an attended experience. So you have to actually be at the console running command lines and authenticating whatnot. So that's not quite ready, but they're working on it, and it's going to happen. This is going to change quite a bit. And with Azure Container Apps, well, running web applications, web APIs, just backend jobs that do something, all of those are going to funnel into Azure Container Apps. .NET Aspire architecturally has been designed so that to feed applications into Azure Container Apps. Can it work with App Service and others? Yes, it can, and you can make it work, but the main use case has been Azure Container Apps. So that's going to fit like a glove. That's where they're doing most of the testing. Okay. I want to talk about the topology of what an Azure Container App is, and I want to compare that with Kubernetes. I know that we're probably split, with some people having done some Kubernetes work and then other people not doing any Kubernetes work. And to be honest, Kubernetes came up, well, Docker in general came up from the Linux community, because for the longest time, Microsoft has invested just a ton of effort into compatibility and making sure that things work on Windows servers really well together. They don't step on each other. And for decades, it's been very common to deploy multiple things to a single Windows server, and they work just fine. There's a synergy between major dependencies. They don't step on each other. For example, if you're doing web apps, well, you have an IIS server, and you could have, it's frequently, dozens and dozens of web applications on an IIS server, and then you create two of those servers, or three or four, in a cluster configuration for a web farm, and it works just fine. And then you have some other, scheduled tasks in the background. Um, and so that was just the case. Now, for non-Microsoft technologies and people who were using, Linux servers earlier on, that was not the case. And all the technologies that that are out there, from PHP to Python to Java to Ruby, and C++, there are on the Linux front, and just the whole ecosystem, the there was and is still the problem of dependency conflicts. And so you put all kinds of applications on the same server. Well, they have a different mix of dependencies that conflict with each other. And so the Linux part of the industry had a problem where segmentation of the operating system was absolutely a necessity. And that's why containers have been more of a thing for Linux than Windows, because it was super, super painful. Mixing multiple applications on the same Linux server and a different mix of dependencies. The dependencies conflicted with each other, and it just didn't work. And so containers were an absolutely required solution if you were deploying to Linux servers. There wasn't any way around it. And sure, Microsoft created Windows containers to do kind of the same thing for Windows, but most people don't need Windows containers. Most people don't care about Windows containers, because we just don't have the same pain that you have with the mix of technologies that typically go on Linux servers. And the tends to be that the only people who are using Windows containers are ones with legacy applications that do have conflicts, or they want to have special needs. But the average .NET developer is not going to care about Windows containers. It's just not going to happen. But let's go back over to Linux containers. And what has happened is, with Azure and other cloud providers, um, the very, very thin Linux server has been very economically viable. And then adding the container technology on top of Linux has made the density at the data center a lot higher than the density for comparable Windows servers. And so Azure and AWS and everybody has adopted Linux as kind of their base server for applications. And then it became hard to manage, and so Kubernetes sprouted up as a community project, and some really smart people figured out how to orchestrate and manage lots and lots of containers on top of a Linux server. And then, of course, not just one Linux server, but clustering multiple
Hola,
servers together.
empezar un bocadillo rústico de comida para llevar.
It looks like we had somebody unmuted. So that's kind of how it sprouted up. And now we have Azure, which has Azure Kubernetes Service, where you can sprout up a Kubernetes cluster and you can use all of the features of Kubernetes. But for most .NET teams, you don't need all the bells and whistles of Kubernetes. You don't need all the knobs. It was built initially by some people who were in very large environments with lots and lots of challenges. And so you pull that back to smaller teams or smaller applications, you don't have all those challenges. You just kind of need some basic clustering. You just kind of need some basic orchestration on top of the container. So you don't need all of the knobs and switches of Kubernetes. You just need a few. And so Azure created Azure Container Instance as an attempt to have a simpler interface. And that's available in Azure right now, but it didn't really meet the mark. It doesn't have the most streamlined experience. And so the new service as of a few years ago is Azure Container Apps. And I want to go over the corollary between that and Kubernetes, because Azure Container Apps literally is a layer of usability on top of Azure Container Service. Okay, so you can create AKS, Azure Container Service in Azure, or you can create an Azure Container App that is basically going to be a slice of an Azure Container Service. Now, there's a few concepts I want to talk about, and that is the Azure Kubernetes cluster. So you're going to see two services in Azure. One is called the Azure Container Environment, and one is called the Azure Container App. You can't just go in and create an Azure Container App first by itself. You have to create the Azure Container Environment as well. A lot of you are probably familiar with Azure App Service, and same thing. You can't create an app right out of the bat. You have to create the service plan. And the service plan is kind of the umbrella where you define what kind of server you want, how much memory, and all that. And then you can create, a good number of apps within that service plan. It's a similar parent-child relationship. You have to create your Azure Container Environment. And when you do that, you are effectively getting access to a Kubernetes cluster. Okay, that's what you get when you create your Azure Container Environment. Then within the environment, you can create any number of container apps. And when you create a container app, you are creating a pod, a Kubernetes pod. Within a pod, you can run a number of containers. And I'm not going to go into it, but if you're looking into this, you want to look into the Dapr service, DAPR, not to be confused of the micro ORM, DAPPER, but DAPR. And when you configure that as a part of your Azure Container App, it gives you some things for free. You add the Dapr libraries to your application, and it takes advantage of multiple containers running inside a single pod, and it's called a sidecar container. And it because the Kubernetes cluster around the pods is going to do virtual networking for you, is going to isolate you in your own subnet. DAPR allows you to basically register that you have some code running in a container, and you register a friendly name in Dapr, and then from another container running in a different pod, you can basically ask the library, hey, can you give me the URL for this friendly name? And you don't have to configure URLs and ports and, hey, where is this other guy running? If you have one process that needs to call an HTTP endpoint on another process that's in a different container, it basically it makes me think of dependency injection at the runtime level. You can register yourself, and then other people can discover where you are within this Kubernetes cluster, within this Azure Container Environment. And so if you think about an application or even a system of multiple applications that has 12 processes running, 12 containers running, doing various things. You got a web service, you got some web app, you got a front end web or a public web application. Maybe you've got a back end administrative application. You've got, half a dozen in-service bus endpoints sitting, just listening for messages coming in over a queue, processing those things. You've got a dozen processes running around, all doing little things. Each one of them is a container that is deployed to its own independent Azure Container App. But when it starts up, it's registering its friendly name with the DAPR, the Dapr service. And when one of them needs to call another, you don't have configuration hell when you're deploying to make sure that you poke into an environment variable configuration, the address of this other container, you can discover that address with a nice little line of code, a little bit of configuration code, and DAPR kind of keeps track of all that networking. And when you redeploy something, or when you scale it, or when you change something where the underlying IP addresses and things change and rejigger around, you don't have to change any configuration. It's a runtime registry of where everything is running. Now, I will say another thing before I move along. If you deploy one container to one Azure Container App, that's totally fine. It's no big deal. You can also, and that's the normal runtime model, is one container revision per Azure Container App. Now, you can run whatever bit of software that you want inside that container. And so if you want to run a single .NET process inside that container, that's up to you. I mean, it's defined by the Docker file. Whatever you choose that to be, that's what it's going to be. Okay. I will show you later. You can run multiple versions of a container image, and there's opportunity for kind of load balancing percentages of traffic from one to another. But your basic use case is that you're going to have one container and you're going to run it in one pod. Well, by definition, the pod is the Azure Container App, and you're going to have multiple Azure Container Apps, which are each a pod inside your Azure Container environment, which is a Kubernetes cluster. All right, so that's the underlying architecture. And I think the rest will make sense once you understand that. You see on the bottom, the Azure Container Registry. That is another Azure service. If you don't already have one, you will need to create an Azure Container Registry. You will create one of these for you'll create one of these per software system. And I'll kind of give you a tour of it. The Azure Container environment is going to live per production or non-production environment, because you don't want to have non-production and production apps mixed in the same Kubernetes cluster. And so effectively think about it. You want to have a Kubernetes cluster for production. You want to have a Kubernetes cluster for your manual test environment, and you want to have a Kubernetes cluster for your automated test environment. And that way, you can deploy all of the apps that make up your system on their own environment. So, and then outside of each environment, you have the Azure Container Registry, which is the corollary to Azure Artifacts, or a NuGet server that's going to have NuGet packages of deployable artifacts that are produced from your build server. Or if you have zip files put in Azure Files or blob storage or somewhere, or even if you save them to Team City or the Octopus Deploy NuGet server, the corollary with the place where you have put your release candidate packages ready for deployment, that is Azure Container Registry. And so Azure Container Registry is not per environment, it is per DevOps pipeline. Okay. All right. Let's move on. So let me talk about the DevOps pipeline. The good news with Azure Container Apps is that it's a new way to run your deployable .NET processes, but it actually doesn't change the fundamentals of DevOps automation or all of the capabilities that you need within a complete DevOps environment. Let me start from production and work my way backwards. So in a deployment pipeline, you need a minimum of 3 environments, because there are 3 categories of environments, and you need at least one of each. Everybody knows production. You need one of each, right? You might have multiple, but you need one of each. Moving back from production, that manual test environment, you need at least one environment where somebody can manually check on something and test something. Most teams have multiple manual test environments. They might have one called staging. They might have one called test. They might have one for product management or customer support, or they might have one for the sales team to do, you know, demonstrations of the next version. It's common, but the category is manual test environment. You need at least one, and most teams have more than one based on the needs of the organization. Backing up from that, you need the automated test environment. I like to call that environment the TDD environment, to invoke, you know, test-driven development, because all these names tend to have three-letter acronyms like UAT or SIT, or some people call them DIT. But I like to call it the TDD environment, and that's for test automation. This environment, there's no humans allowed. All it's doing is run completely automated full system tests, whether they're Selenium or Playwright or Fitness or whatever test framework that you have. It's just, you know, it's loading dummy data into a database. It's running some scenarios. It's blowing away data. It's redeploying. It's stopping and starting things. And so for a person to go and do something on that type of environment doesn't make sense, because everything's being yanked out from under them in the first place. Nothing is stable in a test automation environment. But you need at least one. And of course, to the extent you want to parallelize and run your full suite of full system tests faster, you may have two, so that you can split those tests and kind of assign them to different environments. Pulling back from that, your package management, that is going to be, if you're going to Azure Container Apps, that is going to be the container registry. You're gonna register container images as your release candidate format, and package management now is going to have an Azure Container Registry, whereas before you might have just had Azure artifacts in Azure DevOps to store, you know, your packages as zip files or NuGet packages. And so for the containerized deployable processes, you'll put those in Azure Container Registry. And for the deployable artifacts that are not containerized, you would still use things like Azure Artifacts or Octopus Deploy's built-in NuGet server. And then backing up from that, your continuous integration build and your private build processes, those don't actually change. The only thing that changes is the command lines that are in the command lines to actually package them. You're actually gonna be running Docker commands to create containers, instead of just, you know, pushing it to NuGet package or, you know, zipping up files. Okay. By the way, I was showing you the top third of a DevOps architecture poster, and this is the full poster. I know it's high resolution, you can't read it. By the way, if anybody would like the full high resolution version of this DevOps architecture poster, then just send me an email. I'd be happy to send it to you. It's meant to be sent to a print shop and printed on like 2-foot by 3-foot paper. Actually, I think I might have. So here's the poster. I know you can't see it because of the blurring, but yeah, that's the size that it's meant to be printed. You can put it on your wall. So if anybody wants that high resolution PDF, just let me know. Happy to send it over to you. Okay, let's go into demos. I want to show you some things. And these are the URLs. And if you want to do a screen grab, then you can do a screen grab and look at those. Actually, I'm just gonna help you out and copy and paste into the chat so nobody has to worry about that. Okay, there we go. Okay, I'm going to switch over and show you an application, and I'm going to skip through these because these are self-explanatory. But let me just switch over and do some kind of overview demos. So the one URL I gave you was for a GitHub repository. If you just clone this and run the private build, then you'll be able to get going with it. And it has in here a Visual Studio solution that's very basic. It's the skeleton. It is the skeleton of the application. And it has configuration for Azure Container Apps. You'll want to ignore the Maui parts to it. We're kind of adding some Maui capabilities. But if you're interested, it also has configuration for a pull request template for GitHub. It also has full configuration as code for Octopus deploy deployments, if that's interesting to you. And it also has the build configurations and deployments for Azure pipelines. So here's the YAML for that structure. So it can help you get jump started if you want to use this as a skeleton. Okay. All right. Also, the URL for a project here. I'm not going to dive into it, but I'm going to show you, I'm going to jump right into Azure since we're focusing on Azure Container Apps. And I'm going to show you what we have. So let me go to let me find the container registry. And I believe that's actually outside of it. So let me go here to the container registry. And if you've never looked at the container registry, this is what it looks like. By the way, the Azure portal, they've recently done a kind of a reorganization. And so they've put various things in some of these sub menus because the left side has gotten so long. There's so many things that they're kind of reorganizing everything. And so what we're doing is uh, this is our Azure Container Registry, and we're looking for our repositories. Okay. Now, if you've never used an Azure Container Registry, I know just Container Apps is going to push a lot of .NET developers to use containers for the first time. Some people have been using it for a long time, and that's all great. But it's going to push the normal .NET developer to use containers for the first time for many. And inside the container registry, think of the container registry as a NuGet server. Within a NuGet server, you can have many feeds, and the feed is your application. So you have the registry. Within it, you have a repository. The best naming convention for a repository is the name of the application that you're going to be deploying. And so inside my Visual Studio solution, if I had a web UI, a web application, and in this example, it was called churchbulletin.ui. Okay, that's just a regular web application. And I take that name, make that the name of the repository. And now inside, I clicked inside. Now inside, every time I run my integration build and have a new release candidate, a new build for that, well, now the image tag is my build number. All right, so simple taxonomy. Azure is going to let you call your repository anything you want. It's going to let you call your image tag anything you want. But make the repository the name of the application and make the image tag the build number. That's going to be the simplest thing for you overall, because ultimately you don't want to accidentally treat this like a pet and give it a name. You want to treat it like cattle. You're giving it numbers, okay? Because ultimately, maybe you set it up for the first time you're working with it, but after that, you want everything to be automated, and you're not even looking at it. You just want it to be automated. And so we found that is the best way. That's the best way to have just a traceable convention, because ultimately, when you have a dozen deployable apps in your system, well, you're going to have a dozen repositories, each with the name of whatever that deployable app is for your web service app, your in-service bus endpoint 1, in-service bus endpoint 2, whatever the names of the processes that you're deploying. Each one is packaged up as a release candidate with everything necessary to deploy that process. And so each one of those is going to be a repository. And within each repository, you're going to have multiple images, but each of the images are just a different version of that same deployable process. Okay. So that's the convention. That's the easy button. Azure is going to let you do anything, but that's the easy button. Just do it that way. Okay. And so you click on one of these images, and you can see all the Docker stuff. And you can see the command if you want to pull that exact image using Docker pull. And you can see the manifest, which is all the JSON that, we don't want to read ourselves anyway. Okay, so that's the structure of the container registry. And let's see. I'm just gonna, by the way, this is the app, this is the like default Blazor template, and we just kind of piggybacking off of that. So there's nothing fancy here. And we upgraded to .NET 8, but we didn't change the text, by the way. So all right. /version. All right. This is an extra web API controller. And all it does is look to see what version I have. Okay, it looks at the stamped version of the assembly, literally the DLL file. Okay, so 11783. Boom. Now, if I go into, let me go to the right one. Make sure I'm in the right one. Yeah, okay. So if I go into this, revisions, and 11783. See that? Okay, so there's our traceability. And by the way, this goes for Azure Container Apps or any other app. Actually, I've been advocating for this technique for a long time, and that is in your where was I? In your application, make some place where it's very obvious to go and look and say, hey, what version am I running? And if you have confusion, do something so that it's obvious to see what environment you're running in. There are some people that will will augment the CSS style sheet and put like a very obviously colored border around the outsides just to let you know that you're not in production. Or color coded depending on, but just those are things that are good to do regardless of what type of software. Just make it easy on everybody, because especially when you're testing, somebody needs to do a bug report. It needs to be obvious what version of the software we found the bug in. So make it easy. But also with container apps, we have the tag and we have right there. So what we're going to do is we're going to go through this container app. We're just going to walk the topology. So I talked about the Azure Container Environment. Let me just switch over. Here's the container environment, and it lives inside a particular resource group. By the way, let's talk about resource group organization. You want to make sure that you limit the resources that are in a particular resource group to a single environment. That's going to be the easy button. Again, Azure will let you do whatever you want, but you don't want a jumbled mess. And so the easiest segmentation for a resource group is one environment. So if you have a UAT environment, boom, have a UAT resource group with all the stuff for UAT. If you have staging environment, same thing for that. If you have your TDD environment, same thing for that. For your prod environment, same thing for that. But for production, the best advice I have is put production in a separate Azure subscription. Now, Azure has role-based security, and they have the capability to where you can create a harder security boundary around a particular resource group and only certain people, and you have to elevate privileges to even see inside production resource groups and all that. Yes, it's technically possible to do that in Azure, but it's not easy. It's not the easy button. The Azure subscription itself is inherently a hard security boundary. And so when you're thinking about the concept of production versus non-production, it's easier to put the production resource groups in a totally different Azure subscription that is a production Azure subscription. And think about it. All of your billing is at the subscription level, and production, production bills, they need to go probably to a certain different place. And then non-production is more elastic, and we turn things off and we say, hey, you know what? The team is pretty much, not going to be working either over the weekend or a 3-day holiday or whatever it happens to be. Guess what? Everything in this subscription, let's just turn it off because nobody's going to be using it anyway. We talk about things like that to manage our budget. We don't have those kinds of conversations with production. So having that hard separation is a good thing to do. Okay, so this is the container apps environment. Within apps, I can go and I can create any number of different apps that are going to run inside a container inside this Kubernetes cluster. Again, it's a synonym. Azure Container Environment is Kubernetes cluster. So you can already see that Azure is making it easy for me to even put a function app in here. Why? Because Azure is just going to bundle that thing into a container for me and run it as a pod inside inside an assigned node inside my cluster. By the way, there's no corollary in here for a Kubernetes node, okay? Because that's just being managed for me. I have a cluster at my disposal. I don't have to manage the concept of the multiple servers that make up the multiple Kubernetes nodes in which a pod exists. Azure just does that for me, and I'm glad it does it. Okay, so let's look at a few things because this on the left is actually quite new if you've used it before, and that is ingress. This is where you can do some DNS, you can have your own URLs and all that. And there's so many different, I'm not even going to talk about all the settings because that would be going deep, but I am going to go into user group prod. Okay, that's what it stands for. And you have your application URL. And by the way, if I copy that and I put it in the chat, and I can invite everyone to just click on it and then go to the /version URL, and you should be able to see that come up. Okay, so I'm going to highlight a few things within here. Actually, let's just do a little live demo, which is the riskiest, and let's see if it crashes and burns or not, because it shouldn't. All right, I'm going to go to revisions and replicas. And if I want to manually deploy using click, click, click on the mouse, I can come into the active revision and I can see what's there. Or I can go to containers and I can say edit and deploy. If I just want to change it, and I click on the name and I see that my registry has come up. Okay, I can see that the image. By the way, this is a little bit tricky if you've never done it before. You see the name of the image. It's labeled image here, but what are we really looking for? We're actually looking for the repository name of the registry that we selected. So this label really should be called, repository, registry repository, right? Because that's effectively what it is. And then the image tag. All right, 783. So we have 783. You know what? We're going to go back one to 782. And by the way, this is where, but with command lines or not, you can choose to run, some percentage of a CPU core or 2 cores. You can give it some amount of memory. And this is where you add environment variables. By the way, with container images, they're immutable. If you're used to poking in things into app settings.config, or even older web.config, if you're used to poking in things into app settings, that doesn't work anymore because images are immutable. So whatever you package to the image is configuration that should be constant across every environment. Okay, it should be application level configuration, not environment level configuration. The environment level configuration when deploying with containers here is done via environment variables. So connection string to a database, address of a subscription or topic queue, whatever happens, any kind of URL for an outside payment service or something like that. You're not going to poke it into a config file. You're going to add an environment variable, and you can have the source be plain text if it's not particularly secret, or secret with, Azure Key Store, or, someplace where nobody can go in and, um, you know, look at it in plain text. Okay, let me get rid of these. And we're backing up to 782. We're going to hit save, and we're going to hit create. So we're deploying a revision, and this typically, what it's doing, think of it, if you're familiar with app service, it's spinning up the container. Now the container is warm. We test to make sure it's online. And then under the covers, it does the same thing like a VIP switch in app service or a staging slot. But Kubernetes had the mechanism of bringing a new container on board in the pod and then changing the networking. So boom, now the other one is instantly active and there's no perceived downtime. So I'm going to come over here, and we're 783. I'm going to click here, moment of truth, 782. Did everybody else who's following along get 782? Good. All right. So that's basically how you do it. Now, command lines, that's actually what's more interesting, is the command lines to do an upgrade. And it's not that hard. It's the AZ command line. And by the way, I don't have time to go into it, but if you go into let's see, what file are they in? If you go into, is it Azure Pipelines, delete, that's in the Octopus deploy configuration. I'm not gonna go splunking into there, but all the command lines for operating Azure Container Apps in a totally unattended automated way are in this Git repositories, Azure Pipelines, and Octopus deploy configuration files. So you can kind of see what command lines and what command line switches work. The last thing that I'm gonna touch on is when you create the app. Oh, by the way, I'll talk about one feature. We can choose the revision mode. We can change it to multi-revision. What that does is it allows us to have multiple active revisions, and then it enables this little text box so that I can actually have 50-50, or I can have 80-20, or I can have 80-20-5-5, or 80-10-5-5, and I can literally split the traffic between multiple revisions. And that's kind of another way to do application level feature flags or traffic splitting. If I want to just kind of test out something new, that capability is available. All right. When you create a new Azure Container App, it is not online by default. That's actually a change from when the first version of Azure Container Apps came on. By default, this enabled checkbox is not checked. Okay. So they've changed it now so that when you deploy to Azure Container Apps, it's not immediately open to the world. Okay, which is a good change, because there's a lot of containers that don't need to be open to the world, especially if you're just running in the background, listening to a queue and processing messages. It's not something that you even want a public network connection to. And so to get a URL like what I just showed you, you click the enabled box there, and then you change from limited to container apps environments, meaning pod to pod or app to app communication, to click on this, which is accept traffic from anywhere, so that now it's actually on the internet and you can get to it. All right. And then you've got some additional settings that you can mess with. But in the most basic forms, if you create a new Azure Container App and you're like, here's it won't give me a URL. Why can't I get online? Come into Ingress, click enabled, change to accept traffic from anywhere, click save, and now you will be online and you can kind of run it through its paces.